Okay, we're going to open this with RFLP. Here you see we have a jet engine that has a specification of schematics. Check our BI essentials for the schematic. Check to make sure the flow directions are proper. Everything's green, so nothing's flowing against the diagram specification for flow direction. Now we can also check connectivity, make sure everything's connected, everything's green. And we can check to make sure the data in session is implemented. So color-coded, says it's implemented, everything in blue. The rear sump is not implemented. In 3D. So let's close this. You can also see, if we look at this diagram component by itself, some of the things that are at work in the background are these ports. So here you'll see there's an output port. Here's another output port, P3, output port, P1, and output P2. And you have inputs, P1 through 4. And P5 over here. So there's logic within this schematic component that's being used to connect the pipes. So getting out of the diagram, we'll go into the physical world. First of all, just activate the engine. I'll change the ambiance to blue design. Here you can see the engine assembly. This is the piping assembly right here. So let's take a look at this piping assembly. We're missing a couple of fittings down here and a couple of lines. But before I place those, let's take a look at, let's choose a line and view the data information panel. Over here, so you can see that that particular rigid pipe is made of 304 stainless. It follows the imperial standard. It's 1/2 inch. And it has a plain square end for an end type. We have the length of that pipe, the linear weight, and here's the logical applicative information back to the diagram. Here's wall thickness. Shows that the outside diameter is 1/2 inch with this wall thickness. Default bend radius is 2D, which is 1 inch. And all of these settings for this particular specification are done by an administrator. And it guides you through the proper application of tubing to the assembly. So we're going to go into fluid design, and I'm going to take focus on this particular route. We'll make sure that this is active. So that'll be my collector for these parts that I'm going to place. So first of all, let's make sure we're on the port option here, which we are, and you'll see that it can pick up the nearest port by selection. And I'm going to further focus my attention on this piping spool, and we're going to place that fitting a second time, well, a fourth time actually, fifth time. And we'll place another one right here. Again, using the focus on this fitting. Okay, so that fitting is placed. Notice it's clocked. Everything's in place there. So now, if we look here, you can see that not only do the standards apply to the pipes, but you also have in styles applied to the fittings. And of course the imperial half-inch, so this is a 150 pound rating, so we can't go over that with our pipes. Well, we could go over it, but probably wouldn't waste the money. So next, let's run a pipe from this fitting down to this fitting as quickly and easily as possible. So I'm going to pick pipe. We'll choose this port. Go to the Add Node Manipulator panel and choose my target port, and make sure that we're missing everything in between. We're using these solution modes. You have orthogonal, but you also have orthogonal with the capability of crossing between the corners on the orthogonal cube. So I chose that one. Looks good. Here in the node table, you can see the XYZ values for the points, the point number, the bend radius. In order to bend, well, there's no bend here, but on the next bend from point 2 to 3, got a 19-degree bend angle. So the bend radius is applied throughout. These can be edited, but then you would be probably messing up your manufacturing. So we're going to leave those alone. So let's get this back over here. We'll exit that route. Next thing I want to do is place a T. So I'm going to go to place part. And this time I'm going to choose a place on segment option and kind of eyeball about where I want that T to land. Now I can choose the subtypes that are compatible here, and the T is what I'm after. And that's at 150 pounds, so we will size the whole system for 150 pound. And at this point I can either drag this angle, get that out of the way, to position the T, or I can hit the space bar and type in an angle and then confirm that rotation. The ports are connected, minimum length feeding into the port. Okay, so now we're going to connect this port with the T using another tube. Go to the Add Node manipulator and choose the best fit route, and I'll choose this one. Okay, so here's our bend information again. So now if we take a look here, this is an externally threaded T. It's welded on these 2 points but threaded on this one. You can go to the data information panel to find that out. So it's an ISO 8434-1 female 24 degree inside. So we're going to have to place some parts there. So to do that, we're going to go to part selection, choose the T, and then choose automatic part placement. This has to be configured, but it is configured on this server, so we're going to choose our fittings. I already know that this fitting set is not the right stack up of fittings, so I'm going to go individually through the fittings. Here's the setup that the administrator has done to select the proper parts. And it's a query. So we'll say OK to this. Next we will need a cone adapter. There's only one choice, so we're going to choose that one. There's two choices for the sleeve. We'll choose a 150-pound solution. And there's two choices for the union nut. And again, looks like 150 pound is the difference. It's warning us that it's going to have to extend this beyond its current bend in order to have enough straight for the bending machine. So that was also set by your administrator. Okay, so now we can confirm those parts are placed. The next step is going to be the creation of a spool drawing. So you could choose what you need on your spool drawing. I'm just going to choose this whole stack of fittings and tubes, and I'll send those to another viewer. So here's the whole stack. So from there we'll create a drawing. And what we want is an isometric view. Go back here and choose a piece of the geometry to start the view creation. It says front view. I want an isometric view, sorry. Wondered why I was waiting still. Okay. So now we're getting an isometric view. We'll click in white space to get it to generate. In this case it looks a little busy with hidden lines, so we'll edit that so that in this particular drawing we won't show hidden lines. Okay, and let's move that view over just a little bit because we need to leave some room for the bill of materials. The bill of materials will be generated as a table. Come here and choose the top level. and tell it to place it here. And we'll move this so it fits our sheet. Now you can see the item numbers, the quantities, title, description, material here. So that BOM can be configured, but this is the default configuration. Okay, so the next thing we want is information about how to build these tubes. So we will have this tube right here, which is this one in the tree, and we'll load it in a new app. There it is. Want to get it into a position that's going to make sense for our drawing view. That's up to you. And we will create another drawing. We want to create a isometric in this part. The isometric is created. The next thing we want is we want to export this data so that we can use it on the drawing. So to do that, we will use the export mechanism right here, export list of nodes. And this will be call it exported for video. Okay. Now, in order to use that on the drawing, I have to reformat it from tab delimited to comma delimited, so I'm going to use Excel to do that. So, exported for video is right here. We'll drop that on to Excel. And here, to double check, we'll make sure it's tab delimited. It is. So we'll save that as a CSV file. So change the extension here to CSV. And we can close Excel, go back to our drawing sheet. And here we want to go to our annotations and do an import from a file. We'll only accept CSV as input, so that's why part of why we did the Excel processing, also to get it into CSV format. Okay, so there. And then we will create a bill of materials for this particular tube. And there it is. So from here you could create your title block, place that frame around your drawing, and be ready to save, print, check in, release. So we've gone through the entire process from the schematics to implementation to 3D, connecting the fittings with tubes, creating this spool drawing with a BOM, and also a detailed drawing with a tube and its bin table for manufacturing. So this concludes my presentation.